In this video tutorial, we are going to use MindFusion WPF diagram library to create an application for writing SWOT analysis of a project. This is strength, weaknesses, opportunities, and threat analysis. The application has a major working area where you can drag diagram items from a list to your left. The diagram items include containers, which hold labels with text. There are also several arrow types. The app can export the diagram to XML and PDF files, and you can load a SWOT diagram from an XML file. We have provided buttons for that. So, let's start. We start with an empty WPF application and use NuGet to install the WPF library from MindFusion. We need two namespace mappings, to the diagramming namespace and to the common namespace. MindFusion.common is where the zoom control is included. If you want to add the zoomer to your app, you should reference the common namespace as well. We will use Grid as layout manager. We need a grid with 2 rows and 2 columns. The first row and first column are with fixed height and width, respectively. The other row and column take all the available space. The next thing we do now is initialize a diagram view. The diagram needs a diagram view to render itself onto. The diagram view can be 2D or 3D, and there are a few other options, but you cannot render only a diagram. It needs to be in a diagram view. We place the diagram in the second row and column, where it takes all the available space, left from the row above and the column to the left. Now, if we run the application, we should already be capable of using some basic diagramming functionality. And yes, that's right. Let's set some properties on the diagram view. First, we want the diagram items to be editable, so we use the Allow In-Place Edit property for that. We also set Allow Drop to True, which allows us to drop items onto the diagram. We have to decide which will be the measure unit of the diagram. Let's see the options in the API reference. You can check the list with properties of the library from the online documentation. It is quite detailed, with many tutorials and tips. Time to initialize the node list view. It takes the first column of our application. The node list view is a control of type list, and it holds node instances. When the user drags a node from the node list view, a copy of that node is added to the diagram at the place where it was dropped. Let's add our first node to the node list view. It is a container node. These nodes can hold other nodes and change their size accordingly. We set some styling on the container node and specify the height of its caption. Let's customize the node list view control further. We change the size of nodes, and we change the size of newly created nodes. You can see here the difference between the default look of a container and the appearance it has after we've customized it. You can check the container node class for a list of the available properties. There are quite a lot of them indeed. We add 4 more containers. They are identical to the first one. The difference is mainly in the color. Time for some other nodes. Let's add a text node. That will be a shape node, the most popular type of nodes, that has some styling and renders some text. The shapes of the nodes are described in the table of predefined shapes in the online documentation. You can set the shape to any of those strings. So, our text node is fine. Let's add some other nodes. We add now a transparent node, which also renders text. We add 3 more shape nodes, which are mainly arrows from the list with predefined shapes. Note that we can change their enabled handle style property. This property specifies what type of handles are rendered on nodes, which in turn specifies how the user will be able to modify the node. We set enabled handles to all for the last 3 nodes. The main difference is that they can be rotated, while the containers and the text nodes can't. Did you see that we managed to draw a new node with the mouse? Well, this shouldn't be possible, and we must turn it off. This is specified with the behavior property, and we set it to modify. There are a lot of options for behavior as well. You can check them in the reference. Let's copy the images for the buttons in the project directory. We'll create the buttons in a stack panel above the diagram. The first button is for changing the Z order of a diagram item to a higher one, e.g., the item moves to the top. This is necessary because when the diagram items overlap, you might not have the right one at the top. We override the content template for the button, so it renders both an image and text. In the event handler of the click event, we get the selected item, if any, and change its z-index. We need to change the build action of the button image to be content, and to also specify it should be copied to the output directory. We also add another button for pushing the selected diagram item to the bottom. We need one more button for export to PDF. Before we continue, let's change the properties of all image files. They should be content and should be copied to the output directory. PDF export of the diagram is handled by the PDF exporter class. We also need to create a Save File dialog instance. Sample code is abundant online. Our dialog will filter only PDF files. If the user types in a name, we get it and provide it to the PDF exporter of the diagram. Let's test how this works. We export this very basic diagram. Here's the file. Yes, everything seems to work fine. We need to add now a button for export to XML. XML export is not done by an exporter, but by a method called directly on the diagram. We need again a Save File dialog instance, this time for XML files. Let's see how it works. So far, it seems fine. In order to test if the export was successful, we should implement the event handler of the Load from XML button. The code is identical. We need Open File dialog rather than Save File dialog. We also call diagram load from XML rather than save to XML. Let's see how this works. Let's import our file. Here it is. Good. Do you notice one thing? When we want to add a label, we want to have an elongated rectangle, but the new node is always a square. We can change that. We can handle the node created event, which is raised when a new node is created. There, we can check if the new node is this text node, and if it is, create it with a different shape. So, how do we recognize the node? We can use the tag property of diagram item, from which the shape node derives. There, we can assign a string ID to the node and then check if the new node is exactly the label. We should do this for the two types of labels, the transparent text and the text rectangle. And here it is. It seems to work perfect. With that, our application is ready. We have an app where users can create lists with points to note for a project, milestones, execution steps, or whatever needed. The use of those diagrams goes well beyond SWOT analysis. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.